All right. So, first of all, I have to say that I have gathered some of the information for this webinar from tutorials that, the excellent documentation that's on the developer side of the ARTIK Cloud, but also some tutorials I found, and first of all, the one by Monica Houston and another gentleman who did a Maker 1000 tutorial, so I took some inspiration from it. And here you can find the links to these tutorials. So let's get started. So the idea here is that we're going to be building a simple device, which is a simple Wi-Fi device which reads the temperature and sends that information over to the ARTIK Cloud, where you can visualize the information and you can then connect it to other devices, to different applications. So let's go step by step with what you need to get started. Well, first of all, you need an account on the ARTIK Cloud. So if you go to this URL that I've written in red, you can sign up for the ARTIK Cloud, and you get a free account, which is pretty good. You can send up to 150 messages a day, but also there are all those some paid profiles that are actually very, very inexpensive. So you can actually really build upon this technology, and it's a very powerful and fairly simple to use cloud platform compared to a lot of other products that are out there. Let me show you. Well, I guess either a number of you have already done this, or maybe I'm just going to give you a couple of minutes if you want to do it now. And I'm also going to show you another tool we're going to be using today. So I'm going to be using this thing called Arduino Create, which is kind of the latest incarnation of our online, of our development environment. So you're probably familiar with the classic Arduino IDE. This one is a new version, which basically sits in the cloud. You only need a browser to connect. The interesting thing about this platform is that we're trying to create something that makes it easier for people to collaborate and share. So if you see, this is kind of the front page of Create. So the one I'm going to explore now is the one on the top left, the Arduino web editor. But on the top right, you see this Project Hub. So Project Hub is a platform that we developed in collaboration with Hackster.io, and basically you can share projects over there, and you can also connect your project with code you have in the online IDE. So when somebody looks at your tutorial, they can click on the link, they can see the code, and with another click, they can import your code directly into their Arduino Create. So what I'm going to be doing today, I'm going to give you some URLs that if you visit the URLs, you'll see the code I'm using, and that by pressing a button, you can import them into your online IDE. So once you go there and you sign up for this, then you go to create.arduino.cc, as you can see here, create.arduino.cc, and you will be able to install, you have to install just a little application we call the Arduino agent. It's a tiny little app that sits in your menu bar or in your tray on Windows, and just allows the browser to talk to serial ports, because a lot of the devices we use, they basically simulate serial ports. And right now, there is no official universally supported way to do this. So we are using this little agent. So once you're all set up, you will see this page that says, "Congratulations, you're all set." So once you've done this, you'll have your account created on the ARTIK Cloud and your account created on the Arduino editor. And let me give you a preview. So this is a preview of the Create IDE. You basically have the same things you have on the regular IDE, but you can see here at the top that it says create.arduino.cc/editor, and there's a URL that looks a little bit like a Google Doc. So basically, this is a shareable URL. So if your sketch is public, you can just exchange it with somebody else, and they can basically enter and see the code. There's also a button that lets you embed the code on other websites and stuff like that. You also have a serial monitor where you can see the data going in and back and forth from the device. So let's say that you're all set up and you have your tools ready. What materials do you need? First of all, you need this Genuino/Arduino Maker 1000. So this is it's an interesting device. It's just like 1 inch wide and maybe 3 inches long, give or take. It's a small board that runs on a Cortex-M0 plus 32-bit ARM microcontroller. It has Wi-Fi. It supports SSL. It supports proper SSL. There's a bunch of Wi-Fi tools that makers sometimes use that don't support real SSL. It also has a crypto chip on the board, which can be used to securely store keys and secrets and to accelerate sort of encryption operations. So it is designed as a tool to create connected devices. Also, you can see on the top left, there's a connector where you can plug a rechargeable battery. So if you plug a LiPo battery and you connect it through a USB cable, you can recharge the battery like the same way you recharge your phone with them. So this thing is designed to create Wi-Fi devices that securely connect to a cloud, and it can be made portable with rechargeable batteries. So it's designed to create small wireless IoT devices using the standard Arduino development experience that you are used to. So all of the things I show you today is you can also do with the classic Arduino IDE, but I'm using Create because of the simplicity of sharing the information. The second thing we're going to need is a TMP36 temperature sensor. So this is a very classic temperature sensor. It is described on the datasheet as a low voltage precision centigrade temperature sensor. And basically what happens, this device provides as an output a voltage which is proportional to the centigrade temperature. So they don't have any calibration, it's fairly accurate. So it is a very simple device that works very well. You can see here a picture. The way you use it is very, very simple. The pin on the left, it's the V-in, so you connect that to a power supply. In this case, the Maker 1000 is a 3.3 volts device. So we're gonna be powering this at 3.3 volt. Then the pin on the right is ground, so you connect to the ground on the Maker 1000. And the pin in the middle is V out. So basically that pin will output a voltage which is directly proportional to the temperature measured by the device. So here's a little graph that you can see. So the red line represents the function, the output function of the TMP36. So you can see, for example, that at 1 volt output means 50 degrees. And 25 degrees means that the output is going to be about 0.75, something like that, volts. So there is a direct correlation, and there's a simple formula that you can use in Arduino to convert the information into an actual temperature. And also I'd say that this sensor tends to respond much faster than other temperature sensors that people are used to, like classic thermistors. So this is a little bit more sophisticated and simple to use as a sensor. So here is the first link. If you go to this link, you will be able to see the code for a simple for a simple code that reads the sensor and prints out the temperature. So let me click on the sketch. So you can see here, I clicked on the sketch. Since my Arduino Create has already detected the presence of my Arduino Maker 1000, it's connected. So I'm going to upload this code while I just give you a little explanation of what this code does. So this is just a simple piece of code to test our board, make sure it's working, and make sure that our our sensor is correctly connected. Let me just give you a preview. So this is the board currently running next to me. And you can see here, this device here is the TMP36. So in the meantime, the Arduino IDE has uploaded the code on my board. If I open the serial monitor, I will be able to see the information. So at the moment, the temperature is fluctuating a little bit between 23.8 and 24.1 degrees in this room. And this is also because there's probably there's a fan running in the room, so the temperature probably, there's some wind that kind of goes past the sensor. If I touch the sensor, the temperature should start to go up. So you can see it goes 25, 25, 26. So the sensor is responding. So let me just give you a quick idea of how this works. Let me see. So the idea is this. We're going to be reading we're going to measure the output coming from this sensor from an analog input on the Arduino. So basically what happens is that a normal Arduino board will read whatever voltage it sees on a certain analog input and translate that into a number between 0 and 1023. So a standard Arduino has a resolution of 10 bits. So it represents voltages with the 10-bit long number. This Maker 1000 actually has the ability to go up to 12 bits, but for uniformity with the other Arduinos, I'm using just 10-bit. So once I have a number between 0 and 1023, I have to convert that into millivolts. So you can see here, I am doing, I'm calling voltage equal sensor value, which is the number I've just read from the analog input. And I've multiplied by a number which I've left as a division. So instead of putting like a constant 0 point something something, I just set the number just to give you an idea of what I'm doing. So I'm dividing 3,300 is essentially 3.3 volts in millivolts divided by 1,024 steps tells me how many millivolts per each step, per each number I read from the Arduino. So once I have that voltage, I'm going to subtract 500 and divide by 10. So this will give me the temperature in degrees centigrade. If you are used to Fahrenheit, I guess you can multiply this value by, there's a simple formula to make that conversion. So what you can see here in what we call the serial monitor, you can see that I'm reading 246, that in millivolts is 738, and then applying the formula, this means I am reading 23.8.50 degrees. So this piece of code is telling us that the Arduino, in this case, it's working. Sorry, let me just switch back to the code. I didn't press the button. Whoa. So here you can see the code that I was just mentioning. If you clicked on the link I gave you on the presentation before, you have the code in front of you. So this is the screen showing the Arduino with with the data coming from the board. So now I want to go back to the presentation and move on to the more sort of the part of the example that is related to the actual sort of connection with the ARTIK Cloud. So in order to connect the device to the ARTIK Cloud, first of all, you have to create a device type. Actually, inside the ARTIK Cloud, there's already hundreds of device types already defined. You even find like classic consumer electronic devices of different kinds. They're already there. So I've created this temperature and fire sensor, which is a simple device which has can represent the temperature, and then has a binary kind of Boolean variable that is supposed to tell you the place is on fire. So I've basically visited this URL that you see at the top of the page, developer.artik.cloud/dashboard/device types. That's the place where you can create a device type. So you have to imagine that a device type is essentially is a way to describe the device that you are going to connect to the cloud, and it is already imagined already to be able to represent multiple devices. So let's make an example. If you are designing an internet-connected toaster, so you're gonna define a device type of toaster with all the different variables and attributes and action that that particular internet-connected toaster can do, and you save it as a device type, and then you can connect an infinite number of toasters, and each one of them will be identified individually, but they will all have the same device type. So in this case, I created the temperature and fire sensor, and the unique name is called cc.arduino.temp&fire. So this data type should be public. So if you are on the ARTIK Cloud right now and you look for cc.temperature and fire sensor, you will be able to find this one. So once I have created the device type, then I have to create the manifest, as I was explaining. So I can press the button on New Manifest. And once I created a manifest, I press the button, I can specify what fields are available on this device. So in this case, I have a temperature field, which is a double in terms of data type, and I've specified that this particular temperature field is a degree centigrade. So already specified this is a temperature in centigrade degrees. And I also have a Boolean field called on fire, which is going to be used by the device to basically alert, look, I think the place is on fire. I've created a simple device. I haven't specified actions, but that's, again, an interesting extension. So, for example, if you are creating the famous toaster, you can use variable to indicate the temperature of the toaster and if the toast is toasting or not, how many slices are in there. But then you could also define actions that could say, for example, start toasting, or pop out the slices. So you can use actions to basically ask the device to do things for you. So once I've created this manifest and I saved it, I basically press the button to activate the manifest. And once the manifest is activated, I can connect as many devices as I like that use this particular manifest. So in this case, I've then jumped to the ARTIK Cloud. I clicked on My ARTIK Cloud, My Devices, and I can basically specify connect another device. So this is the place where we connect the device to the ARTIK Cloud by basically specifying what kind of manifest we're using. So in there I specified, I'm going to be using the temperature and fire sensor, and I'm going to be calling this particular device demo webinar sensor 01. So I have a number of Maker 1000 boards on my desk. I could connect them all and basically send in the same data. And I could call them, demo 1, demo 2, demo 3, demo 4, demo 5, and each one of them will be individually communicating with the cloud, but they will be all sharing the same manifest. So once I have connected the device, I can show you on the ARTIK Cloud. If I go to devices, you can see that I have this demo webinar sensor 01. So if I click on the little gear, this window pops up, which tells me basically the device ID. So this is a unique identifier that uniquely identifies this specific Maker 1000 you've seen in the picture connected to the cloud. The device type ID indicates what kind of device it is. So in this case, it's a temperature and fire sensor. And then you see there's a blue link that says generate device token. If I click on that, this will generate a very long ID, which will be an authentication token that can be used by the ARTIK Cloud to actually determine that the device that's trying to connect is effectively my device and not somebody else's device. So this is the equivalent of an API key type thing. So you can see here, I have it on the screen. I have other devices I've worked on. So I'm going to need the device ID, and I'm going to need the number that comes out when I click on generate device token. Those two numbers make sure I can connect this device to the cloud. And now here is another piece of code. So if you open this bit.ly/artik01, you'll end up on a page where you can see the code for this particular sketch. I am going to open now. So I close this. So let's see. So at the moment, I've opened this sketch that allows me to connect this Maker 1000 to the ARTIK Cloud, saying that I am this, specifying the kind of sensor data I'm sending. So in order to use this code, you have to basically provide 4 bits of information. You can see here, it says string device token equal. Here, inside the quotes, you have to cut and paste the device token that you should have generated with the blue link here, generate device token. And then you need the device ID. Here is where you specify the device ID. So if you go here, you see device ID. Obviously, if you copy my device ID in your code, that's not a very good idea, because otherwise the ARTIK Cloud will see multiple versions of the same device sending data. And so please don't copy that. Put your own device ID. And the last bit of information you need is the Wi-Fi password and the Wi-Fi SSID. So this is the SSID. So I'm going to be using a network called Genuino, and the password I'm going to be using is called Maker 10,000. So I'm going to quickly open a version of this sketch which has my secret data in it, and I'm going to hide it for a second. So let me tell you a little bit about this code that we're going to be using. So this code uses 3 libraries from Arduino. The first one is the Wi-Fi 101 library. So this is a library that allows the Maker 1000 to use the Wi-Fi connectivity, SSL, and a bunch of other features. So you can see here in the code that I am using Wi-Fi SSL client. Then we're going to be using another library called HTTP client. This is a still a little bit experimental library that we are working on, but it is essentially a client for the HTTP protocol. So one thing I probably haven't specified clearly yet is that we're going to be connecting to the ARTIK Cloud using a HTTP REST call. So that you can connect to the ARTIK Cloud in multiple ways. You can use WebSockets, you can use MQTT, but in this particular case, we're doing a simple HTTP post on an endpoint that's specified at the beginning of the code. So these two instructions basically create a Wi-Fi connection, and then they create an HTTP client which uses that Wi-Fi SSL connection. And these lines of code here, in the setup function, they are used to connect to the Wi-Fi network. So what happens is that these lines of code keep looping until they achieve a connection to the Wi-Fi network that you specified at the beginning of the code. And then this is the main part of the code. Our objective is to construct a specific JSON message that contains the temperature and the on fire, not on fire indicator, and post it to the ARTIK Cloud. So let me show you quickly. This is a kind of message that we send to the cloud. So JSON, if you don't know, it's a text-based data exchange format, which is basically derived from JavaScript. And so you can see that there's a number of variables where you have a name between a column, there's a semicolon, and there's a quote, and then in the quote you have values, and then you can basically create some data structures, complex data structures, by using the curly brackets to sort of package up the data in different ways. So every time you send a piece of data to the ARTIK Cloud, you have to create a JSON message like this one. So in this case, I'm specifying SDID is specifying the device ID. So this is the ID of the device that's sending the information to the cloud. When the HTTP post is executed, one of the parameters to that HTTP call is going to be our device token, so that the cloud can recognize that this is effectively my device. It's not somebody else's device pretending to be my device. So we're going to be posting a message that says ID of the device, type message, and the data information as temperature and on fire. So temperature and on fire match, the names match what we specified in the Arduino Cloud. And if the post is successful, the cloud is going to respond back with a packet which is a little bit like this. It says data and MID, and so every bit of information I load onto the ARTIK Cloud is basically assigned an ID, and I receive that ID back. So let's see here. Let's go back to the code. So we have here the loop. So if you're familiar with Arduino, you know that every Arduino sketch, as we call it, program, has a section called setup, which is run only once at the beginning of your sketch. And then there's a loop function that just keeps getting executed all the time. So it's an infinite loop. Until you turn the board off, that loop will be executed. So let's see what happens at every loop. We're just printing out on the serial monitor a message that says loop. And we're also, if you want, you can connect an LED to the board. And basically, every time you send out a request, that LED will turn on and off. So we have an LED toggle. Then I'm specifying that I'm making a post request. So I am creating this a parameter that contains the type of content I'm going to be posting. So applications/JSON is what they call the MIME type for a JSON message. And then authorization data is the information I'm going to pass during the HTTP call in order for the ARTIK Cloud to be able to recognize me. Then you can see here there's a line that specifies how to go from the information read from analog input 0 on the Maker 1000 to the temperature in degrees. So I've placed a formula on one single line. Then I'm using I'm putting a tiny bit of logic just to simulate the fire detector. So what I'm doing here, it's very stupid, it's just a little simple piece of code, but I'm saying if the temperature, if for more than 3 times that I measure the temperature over a certain amount of time, if that temperature is over a danger level for more than 3 times in a row, then I think we're having a fire. So this, when the counter goes beyond 3, then on fire becomes true. Otherwise, on fire is false. So this load buffer function, I'm going to explain to you in a second, but basically this is a function that takes temperature and the on fire indicator and turns that into a JSON message and places that on a buffer. So it makes it ready for posting. Then I'm indicating that I'm going to be sending data. So here's the tricky and interesting part. So this is how you use the HTTP client. Basically, you begin a request, then you specify you're going to be posting on that particular URL. The server address was specified the moment we created this HTTP client at the beginning of the code. Then we set the headers. One is authorization, and we provide the device token. We specify the content type. We specify the content length. And then we basically say, okay, now end request. So this is going to package up a request, send it up, and then I'm going to print the content of the buffer. So this is going to send the request to the server. The server is going to process the information, and it's going to send me back 2 things. First, a status code. The status code is the classic HTTP status code. So if everything goes right, you're going to get a 200 as a response, and that indicates that everything is fine and the information was transferred correctly. And then you're going to get a body. The response body is essentially this thing we have on the screen now. So this, you're basically getting back a JSON message with the information about, so the transaction ID, if you want to call it like this. And then I'm printing on the screen the information, I'm toggling the LED, and then I'm delaying for about, in my code here, I'm delaying for about 1 minute. Let's put 30,000 delay, basically stops the Arduino for a certain amount of milliseconds. This load buffer function is not so easy to understand at the first time, but this is using a very, very powerful library called Arduino JSON, which you should check out. So let's, without further ado, I'm going to upload this code to my Maker 1000, which we can see here. And once the data is being uploaded, I'm going to, in a second, the data should be available. So it's uploading the data, it says successful. All right, let me switch back to the code. So you can see here that the data I have posted is a has been received by the ARTIK Cloud, and I got back a response. And then if I go to the ARTIK Cloud and I go to essentially my data, I should be able to visualize the information. So you can see that here, if I press this plus and minus chart button, I can choose of all the devices I connected, which parameters I want to put on this particular graph. So in this case, you can see that there is a little orange dot that represents off, false, and there is this kind of purple line around 20-something degree, which indicates the temperature that I just posted. If I go back to the IDE, I'm going to be sending, oops, I've sent too many messages to the ARTIK Cloud today, so I cannot send much more data, but let me just show you. This is some of the information that I've sent over the course of the day. So you see the temperature has gone up when I was testing the sensor, gone down, and at every request you see the data being exchanged. So this thing is very powerful. If you press the play button here in the corner, it even goes to real-time data. So in this case, if your device sends a bunch of data in real time, you will see this scrolling very fast. Or if I place like 1 hour or 1 day, I can show the data at different scales. So 1 hour lets me navigate the data. So what's happening now is that every 30 seconds, my device is going to push data to the cloud, and it's going to be visualized here. And then I can use, for example, a mobile app or a web app to visualize this information. Or I could also build another Wi-Fi device which talks to the ARTIK Cloud, reads this piece of information, and uses that information to activate, for example, a fire alarm or something else. So the two key parts are my devices, where I can see all the devices that I have connected and specified, and essentially my data, where I get all the different data. There's also some more exciting stuff in the rules section where you can specify rules saying things like, if this device at this time generates a message with this value, then do these other things. So you can actually you can orchestrate messages between the different devices. And so this is the general idea of what I wanted to show you. I wanted to show you how to create a simple example of taking some sensor data and push that to the ARTIK Cloud from an Arduino Maker 1000, which you can see here in the picture. I guess if there are some questions, probably this is a good time to ask.
Let's see. Massimo?
Yes.
Thank you. Massimo, can you hear us okay?
Yes, I can.
Okay, good. Sorry about that. Yeah, we had some slight microphone issues. There are some questions for you, so let's see if it can be answered. Okay, so a user is asking, instead of having the on-fire logic on the hardware side, shouldn't we use an ARTIK Cloud rule to trigger the alert that's fixing and updating the logic?
Yes, you could use you could totally use a rule on the ARTIK Cloud. The thing I wanted to show you is that instead of just having a simple logic that pulls data out of the sensor and sends into the cloud, you can also put a little bit of logic in the device if you want. So this was just a stupid. In a real scenario, we wouldn't be using just the temperature sensor. We would be using a specific sensor that detects fire, and we would send that information. But yeah, putting the rule in the ARTIK Cloud is absolutely equivalent. And actually, in certain situations, it may be even better because you can change that logic in the cloud without having to update the code on your device.
Thank you for that. Another person is asking, can I use the same Arduino code to work with Edison in order to connect it to ARTIK Cloud?
Yes, I would say that you'll have to basically adapt just the initial part where we basically specify Wi-Fi. So you would have to specify whatever connectivity you're using on the Edison. But the nice thing about using Arduino as a development platform is that basically the code I showed you with some changes in the first 5 lines allows you to use the same code on a bunch of different hardware clouds. You can use it on Edison, on Galileo. You can use it on, even on the Arduino Yun, a bunch of other platforms.
Okay, so here's a question for our own ARTIK Cloud experts, and she can answer it. The question is it hard to hand over the data forwarded to AWS or Azure, for example, implementing machine learning? Will Samsung Cloud offer an interface or service?
Yes, and we are working on a feature which will make the third-party developers easily to pass data from the ARTIK Cloud to the Amazons, so that it's easy to perform big data analysis and machine learning. Stay tuned our newsletter. Once we have feature in the production, we will send out this notice.
Okay, so stay tuned for the future. We will send out notification once we have that service or interface ready. So let's see if we have other questions. Okay, this one is for you, Massimo. Can the MKR1000 be used with ThinkSpeak?
Yes, the Maker 1000, actually it's fairly easy to do that because I've done it. And it works with we work with a bunch of different clouds. So it works with ThinkSpeak and a bunch of others.
Okay. Another question again, is it possible to use the MQTT protocol with the Maker 1000?
Yes. Actually, again, because of the way the Arduino code is designed, we have this pub/sub client, which is actually written by one of the IBM people in the MQTT team. And it doesn't matter if you're using Wi-Fi, Ethernet, or other connectivity. So the same code could just be running on top of MQTT. The way we do it in Arduino, we have an MQTT server in Arduino that we use for basic projects, and we do basically MQTT over SSL, and it works very well.
It is. Can I use the Arduino Uno?
Wow, yes. You could use an Arduino Uno. The only problem that you will find is that the Arduino Uno has basically 1 kilobyte of RAM, so you'll have to do a little bit of work in order to craft the messages and all that and stay within the 1 kilobyte of RAM. So it is possible. It's just a bit tricky.
Okay. Thank you so much, everyone. We are out of time, but we will try to answer all your questions, and we will send you the recording as well as the slides to this presentation. Thank you all again, and have a good one. Thank you so much, Massimo. You've done an excellent job here, and thank you. Have a good one, everyone. Enjoy the rest of your day.